All right. So this is the lecture on wireless and mobile networking facts, statistics, and trends. So before we get into the technical part of the course, where we will talk about all the formulas and everything else, it's just good to know what's really going on in the world, right? And that's what this is all about. So we'll talk about wireless history, then what we call hype cycle, then some trends about the speed and other trends and trends and trends. Now the thing is, there are lots of numbers here, and I don't expect that you will remember any of those numbers or I will remember any of those numbers. The idea is just to remember the gross things as to where the action is. That's all. Okay, not that there is 30% action in this place, at 20% here, and 60% growth rate. Nothing like that. But you have to know that, for example, in the last class we said wireless is growing and the wireline is decreasing. That you have to know. Okay, that level of things you can remember, right? So that's the thing. Now, so I'm going to start with this cartoon, which is not actually in the handout, but you really don't need it. And the idea is that this is all the numbers are just made up, not by me, but whoever present. I have references for all of those, but nobody knows the future. Nobody knows the future, really. And so I'm not going to claim that this is all true, because anything which is beyond 2013, and which is what we are interested in, is just a guesswork from on the parts of the people. And most of this guesswork is actually a linear prediction of the past. And the world does not work that way. The world actually, for example, if they would have done the prediction of what will happen to the phones 5 years ago, before iPhone, I think the prediction would have been very wrong right now, right? You know that, right? So the things will come which will change the whole world direction, and so all of this will be no longer good for anything. But what we want to do is, at least given the past, whatever we know right now, we don't know exactly what will disturb this whole thing. We want to say what it is, right? So with that, I'm going to present you some things which may not turn out to be like they are right now. So the history. So wireless actually has been around for over 100 years. And Hertz, whose name will come in every time we talk about frequency, was the one who discovered that there is something happens, when he connects when you connect or disconnects the wires together. And so he first discovered the electromagnetic waves, and he is honored by giving him the unit of frequency. Right? The frequency is measured in hertz, and we will actually talk about more that in the next class. So 1880, right? But nothing really much happened in that until the police started using the radios, and then until really 1970, 1970, when the first cell phones were sold. So people would take a big phone, put it into the car, and that was called cell phone. And really the network that you use today, Wi-Fi, didn't happen till 1997. So the first version of Wi-Fi, which actually you don't use anymore, 2 megabit Wi-Fi, 802.11, was done in 1997, and within few years we found out that it's no good. And so we changed it to 802.11b. And B runs at 10 megabits, actually 11, right? 10 megabits, right? So that is, 11b is what you use, right? When you use 11, you say B, G, and N, right? You don't say 11 alone. 11 alone is not used at all. But we will use the word 11 alone, because 11, when you say 11, that includes everything, A, B, G, N, and AC, and AD, and whatever else comes around, right? But anyway, 1997, so how much is that? That is only 15 years old. Right? In 15 years, Wi-Fi has taken over the world. There is not a single computing device that does not have a Wi-Fi, particularly if it is, not a big monster computer, if it is a mobile thing. All right. So then whenever we talk about the trends, we have to know about the life cycles of the technologies. And this thing applies to every technology, not just wireless. It applies to networking, it applies to computing, it applies to aeronautics, it applies to chemical engineering, and it applies to biological sciences or whatever you want to apply it to. All right? Every technology has this curve where in the beginning it takes a long time to get very little research, very little result. And that means the amount of money that you can make out of this is very little, but the amount of money you have to put in is very large. Right? And that is when it is done by graduate students. Because there is nothing to get out of it, money, right? So this is research phase. This is research phase. This is when we are working on the universities. As soon as the technology is developed to a point where you can start making some money out of it, it goes into a startup, right? It goes into the industry. And at that point, a hype is created. The hype is created that this will solve all the problems of the world, and a lot of money is invested, and a lot of money is made, and then finally it reaches the peak of the hype. At that point, it is clear that it cannot solve all the problems of the world. All right? And then the interest goes down a little bit, which means lots of companies are sold, lots of disinvestments happens, and at the end, it comes to a level from where it can either go down forever and never to be seen again, or it can go down to a level where it will stay for some time. And so this technology, that whenever we talk about some technology, let's say IP version 4, IP version 6, or wireless, or Wi-Fi, or Wi-Fi 11B, anything that could be at one of these points here. If it is here, it's good for the researchers. If it is here, it's good for the startups. If it is here, it's good for some companies or some countries. Generally, basically, this part of the curve is good only for big companies, because very little money is made here. It's just volume. Okay, and so the manufacturing moves to China, and so on and so forth, and big companies like you name the big companies, Microsoft, Cisco, and everybody else, they stay there. The startups are gone. Right? This is where the startups are. And nowadays, actually, this part is shrinking, because basically, there are very few things that are very far away, as shown here in this picture. Actually, the things that start right here, and they're going to start up. Even professors have the startups. So as soon as they come up with an idea, they have a startup. Right? So every year, there is a company called Gartner that prints out hype cycles, and they call it hype cycles, for every technology, believe it or not. And people pay several $1,000s for each of these reports. If you are a Cisco, you need to know what is the hype cycle for IP, for Internet of Things, for this and that. And so this is a big thing, hype cycle. And so what I have shown in this picture is a hype cycle for wireless networking infrastructure, 2013, the latest one that is available for wireless. And what it is showing is that 5G is here, right at the knee. It doesn't even show the part before the knee. 5G is here, and cognitive radio is there. So this is where the startups are. Right? Wi-Fi Direct and 802.11u have gotten to the peak. These things are now, not that, I want to say sexy in that sense, that there are not many people are interested in them, and these have reached the plateau. Okay, so these are like mainline products, LTE. You can't really make money out of it now anymore, because big companies like Qualcomm and Ericsson are making them now, basically. Yeah.
Is there like an average length that it takes for a product to go through the entire hype cycle, or does it vary?
This is very much product dependent, right? There are some technologies that can go down to the drain in a few years, and then some technologies that can stay around for a long time. And basically, everybody, including the big companies, are looking for this part. Right? And you have to be looking for the same part. Even if you are a researcher, you don't want to be doing research on these things here. Okay? Make sense?
So I have a question.
Yeah.
commercially, can we say that these technologies which are on the plateau are successful? Or should we say those technologies are successful which are on the uprise?
Well, I mean, so you have to define the success.
Commercially.
Okay, no, hold on, no. You have to define success. Success is defined that, like, if you put $1 and you get $100, that's a success. If you put $100, you get $110, that's a success too. All right, so this is 10% and this is 100%. Right? This is where the fortunes are made. This is where the business is made. I mean, basically, yeah, you will have a stock growth. Stock will go up, but you want to start a startup there. All right? Okay, so now that we have mentioned so many words there in this, I thought it would be good to just know exactly what these things are, and this is just too early for us to talk about anything because you don't even understand what is a hertz and what is a baud and what is a bit. So I have put just one liner for each of these technologies just in the order that they are in the curve. Okay, and I will just give you one liner so you know what roughly those things are. And then later on, we might go into whole details on some of them and some detail and no detail on some of them. Okay, so 5G. 5G, anything beyond 4G, right? But it will really, technically will come in 2020. Okay, every 10 years a G happens. So 2000 there was a 3G, 2010 was a 4G, 2020 is 5G. Okay, and it will be 100 times LTE. Now, many of you have 4G and you have, that means LTE right now. Many of you have LTE on your iPhone 5 or Android, whatever number. And so, even 4 has LTE. So, basically, it will be 100 times faster than that. But what it is we don't know. Because standards have not been set. This is where the research is being done. Remember, this is the first dot on the curve there. Cognitive radio. Cognitive radio idea is that the radio is smart enough to find its own spectrum. So basically, it will look for if any spectrum, what is the spectrum is not being used, it will use that, and if somebody starts using it, means somebody who has licensed that, there it will get off. So you won't even know that it was there. And it's happening right now. So this is not something too much in the future. 11AH is low speed coordinated communication from machine to machine. So there is a lot of things happening on the Internet of Things where everything will talk to everything else. And so that is called machine to machine. Your refrigerator will talk to your thermometer, thermometer will talk to your iPhone and so on. And so that machine-to-machine communication, for that they need a very low-speed wireless technology, and that is 11AH. By the way, I didn't have enough space to put the full acronyms for things like this, like M2M or LTE. I should put that, but then it will just make it too long here. But all the acronyms are at the end, right? You know that at the end of the handout, if you look, there is a whole alphabetized list of all the acronyms. So if you don't know what is M2M, you can go there. Hopefully it is there. And then similarly for LTE and so on and so forth. Okay, so 11H, terahertz waves. Now terahertz clearly says terahertz, which is 10 raised to 12 hertz. And people who are in the wireless will call them sub-millimeter waves, and this will become clear when we talk about the electromagnetic spectrum later on. And sub-millimeter means that their wavelength is from 1 millimeter to less than tenth of a millimeter to up to tenth of a millimeter, and their frequency is from 0.3 to 3 terahertz, and that's why they are called terahertz waves. And they lie somewhere between the radio waves and the light waves. Okay? And that's the beauty. Like a radio wave, they can get into your body, they can get inside an envelope, they can get inside a box, and they can see inside. Okay? But like light waves, you cannot modulate them. I mean, like radio waves are differently modulated than light waves, and so there is a whole series of things that you need to do. So that is the technology which is coming up, terahertz waves. 11AD is called WiGig. This is gigabit wireless. Okay, this is actually happening. Standards are almost there. So gigabit Wi-Fi. Smart antennas. Now smart antennas are antennas arrays, means in one plate you will have lots of little antennas and they will be directed so that it can be immediately directed to whichever direction you want. You don't have to physically move anything. The antenna is right here and it is directed to that clock over there, so the signal is coming from there. When it is talking to this, it will just automatically move that way. You don't have to move your antenna. Okay, those are smart antennas. Antenna array that can orient towards the direction of arrival. LTE advanced, which is basically LTE version 2, next generation of LTE. This will be the real 4G. So right now LTE is being sold as 4G, it is actually 3.9G. Okay? And so LTE advanced, when it comes, it will be 4G and will be 1 gigabit per second. 11AC. 11AC is actually, you can buy on the market right now. You can go to the Amazon and just put 11AC, you can buy it. 500 megabit to 1 gigabit Wi-Fi. So this is just before this 11AD. Wi-Fi direct is point-to-point Wi-Fi. So if you have Wi-Fi direct, then you can just put two devices, like two iPhones or two phones together in front of them, and they will just do some gigabit transfer between them. Fast, point-to-point. You don't need an access point for that. Wi-Fi direct. 11U is authentication for hotspots. Now, right now what happens is when you go to a hotel and they say, okay, I'd like to log into this thing. You log in and your browser complains that this is not the website and this license doesn't match and the certificate doesn't match. Has it happened to any of you? Right? Do you really want to go over and you say yes, 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 and you remove all your protection and you just agree to everything, and then we will connect to hotspot. Because you are trying to go to Google, and instead of trying to send you to Google, it is sending you to the hotspot owner. Right? And so the technology is trying to protect you, and that's it. So, but the thing is, both are required. You need some people who can charge you before you can go to Google. Right? So this one, 11U, takes care of that. Basically, with 11U, your device can talk first to the authentication and get it authenticated, get paid for and everything else, then it can go to Google. So the browsers will not be confused then. All right, small cells. So the cells right now are like 10 kilometers each cell, each base station covers 10 kilometers. Small cells will cover anything less than that, like less than 2 kilometers. That could include microcells, picocells, femtocells, and so on and so forth. The smaller the cell, higher speed you can get. Yeah.
What is a cell?
What is a cell? Okay, so basically, when you have a cellular phone, the word cellular phone, is that there is a base station somewhere on the mountain or on the top of a tall building. There is a base station, and it can cover a circular area. That is a cell. Okay? 802.22. That's the recent standard for regional area network. So now we have personal area network, we have local area network, we have metropolitan area network, we have regional area network. So metropolitan is a city. Regional is, bigger than a city. Okay? If we put a regional area network here, it could cover all the suburbs of St. Louis. Regional area network. So that is 802.22. Now the thing is, the 802.22 is a standard which uses white spaces. What is white spaces? White spaces are the TV channels which are not used. So the way TV channels work is that everybody gets a 6 megahertz channel. So they have channel 1, 2, 3, 4, 5, 6, 7, up to 79, whatever. These are all 6 megahertz each. But you cannot use all the channels in all the cities, because if you use all the channels in all the cities, they will interfere. So they don't use half of the channel in each city. Right? And if they're not being used, somebody else can use it. And that is called white space. Alright? Super Wi-Fi is the long distance internet access using TV white spaces. So basically, for this super Wi-Fi is similar to 802.22 but different. Okay, 802.22 is not Wi-Fi because it is not 11. This is similar to 11. Okay. TD-LTE. Actually, this is not similar to 11. Let me just put this one. Super Wi-Fi is actually a concept right now. There is no standard. This is a concept which has been basically the term has been coined by FCC. FCC is Federal Communications Commission. Okay. Then TD-LTE. TD-LTE is time division duplexing LTE. LTE is long-term evolution, right? LTE is like we have LTE here in the United States. It's not TD, it is FDLT, it's frequency division duplexing. But in China, they have time division duplexing. Okay? And so TD-LTE, and because China adopted this, many countries that buy the equipment from China, like India, they have TD-LTE. Okay? And we will talk about that too, as to what is the difference between time division and frequency division later on. But for right now, you know that there are two versions of LTE at least, LTE, TD-LTE, and then LTE Advanced is coming. So TD-LTE Advanced is coming too. Zigbee. Zigbee was on the list. Let's see where we are now so far. So we are almost here, Zigbee. Zigbee is personal area network, 802.15.4, but it's the trade name. So just like 802.11 is the standards name, and Wi-Fi is the trade name. Wi-Fi is the name of the organization that certifies that you are following 802.11. Okay, that's the company group, a group of companies. Actually, I mean, a group of companies. I don't want to call it a group of companies. It's actually a, what is the right word? But anyway, it's a industry group which certifies Wi-Fi, certifies 802.11, and so that is similarly Zigbee is the trade name for 15.4. 11R is the fast base station transition. So right now when you go from here to that room, you have to change from this base station to that base station. It takes time. With 11R, it will be much faster because you will beforehand know where you are going and what will be new base station and so on and so forth. You don't have to go and search for a base station there. So that is 11R. LTE is the long-term evolution, 3.9G, but sold as 4G right now. 11N, all of you have it. If you don't have it, you haven't bought the computer in the last 2 years. If you bought it in the last 2 years, it probably has N, right? N is multi-antennas. And 11K is again something to do with the transition. When you go from somewhere, from one base station area to another station area, 11K helps you find the best one. All right. So now you can see that some of these technologies like 11K, 11N. Now 11N has been around. Today you cannot make a startup on 11N. 11N is just made by companies that make in bulk all the, you can buy it for $10 maybe. Okay, yeah.
Just wondering if anything like royalty, like 3.9 or why it's 3.5 or...
Okay, so the question, this is a good question. Why is LTE 3.9 and not 4G? So there is an organization called ITU, International Telecommunication Union, which sets the requirement for the G. So it sets the requirement. In 2000, it finished 3G, and it says, okay, all right, now we want to do 4G. For 4G, this is the requirement. So this set a set of requirements, and they will happen in 2010. All right. So basically, everybody started working on it. WiMAX people started working on it. And they couldn't meet the requirement. And then LTE people started working on it. They couldn't meet the requirement. And so neither of the technologies meet the 4G requirement. That's why they are not 4G. All right. But both of the technologies have done a second generation, WiMAX 2 and LTE Advanced, that meet the requirement. Those will be 4G. But having said that, let me tell you what is going to really happen. They are going to change the definition of the G. Who cares what ITU thinks? they are going to sell LTE advanced as 5G. Period. Done. So basically, they are not going to wait till 2020. They will have 5G next year, but that would be really the 4G. And then ITU may have to change its own definition. But right now, ITU definition is there, ITU advanced is there. There's a set of requirements that you have to meet to make 4G. And actually, I attended lots of standards bodies meeting at WiMAX as well as at 8.16. And we tried to make the requirement for 4G. But even before the technologist people were done, the market has started selling 4G. Okay, make sense?
And 3.5 was probably already around HSDPA and all, so they made it 3.99.
Yeah. Okay, when we go to 3G, then we'll tell you why these 3.5 and 3.9 and 2.5. Yeah, so there are intermediate numbers. Okay, good. So this is actually good. Basically, I think I like these two slides because they tell you what is really happening outside there and where the potentials are. Research is happening, right? We didn't get into really detail as to how white spaces works, or how does the cognitive radio works, or things like that, right? But that will require the whole hour and a half lecture. But right now, at least we know the names, and this you should know, at least in the names, not right now. Okay. Now we get into the trends, speed trends. How the speed is going. Now this is not my graph. Actually, none of these graphs are mine anyway. But I wanted to plot this graph myself, which I haven't done it. But someday I could do it. So basically, what this plots is the year and the speed by that particular standard. So these are all the standards. And this is the year, right? And the speed. And what they are showing is that there is actually a straight line fit between these. So this is actually, first one is not wireless. First one is wired network, wired USB. USB 2 and USB 3. Alright? Wired network. The second one is wireless, local area network. And local area network, this slide says 10 meter, but I would say it goes up to almost up to 100 meters or more. So that one is here. And they have plotted 11AG, 11B, 11, 11N, and AC, AD, etc., and that's a straight line which is parallel to the first one. The third line is cellular. So this is long distance. It starts at 100 meters and goes up to kilometers. And so they have GSM, GPRS, SSDPA, and all that, all the way to LTE. And this is a straight line too, parallel to the previous one. So all of these are really following the growth rate of the hardware, which is Moore's law. What does Moore's law say? That every 18 months things will double. Right? Your computer speed goes up by a factor of 2 every 18 months, and so does this wireless. All the electronics. Everybody knows who is Moore? Gordon Moore. He was actually the first president of Intel, or founder of Intel maybe even. And so he studied Intel's output for several years, and he came up with the conclusion that every year they are increasing it by a factor of 2 every 18 months. And so that has become a law, and surprising to him also that the law still goes on. He retired tons of years ago. But we still are going up by a factor of 2 every 18 months. Okay? Unless that applies to wireless. Except that as you see that the speeds are much lower as you go longer distance, the speeds are much higher when you go short distance, and shorter, the speeds are higher. Obviously. Any question about this graph? Now we come to Cisco. Now, all of you know what Cisco is. Cisco is the networking company, or the biggest networking company in the world, and based here in the United States. And so they obviously keep track of what's going on in every part of networking, and they have something called Cisco Visual Networking Index, VNI. So the next 13 slides are from their study. And this is a page that you must read. Because, they publish it every year, by the way. Just like Gartner publishes their hype cycle every year, Cisco publishes its VNI every year. And every year everybody else reads it and finds out where the networking is going. It's not just for wireless networking, it's for everything, all networking. Okay, so let's see. So for wireless, they have a page called Global Mobile Data. And so global mobile data is increasing very fast, 70% in 2012. It's like this, very fast growth. And if you wanted to have absolute number, 885 petabytes. Now I can't remember any of these numbers, but at the same time, just you have to see the magnitude, that it used to be just 75 petabyte in 2000 and now it is 885, 10 times bigger. The interesting thing is that most of it is video. And that is something that that is something that you can remember and I will remember, is that really the mobile stuff is not just pure data like file transfer. It's what people are doing is watching video, entertainment, YouTube, right? That is what making most of the mobile traffic. And the connection speeds have doubled in just 1 year. Obviously they are supposed to double every 18 months, but this is where the difference of opinion happens. The previous author, which is not Cisco, felt that this was following the Moore's law. Cisco is saying that it just doubled up in 1 year, so it is faster than the Moore's law. So different people will say different numbers, and that's why I was going to plot my own number too. But basically, this is not fixed. All of these are somebody's point of view. Okay? And then 4G has taken over. That was another thing that they're saying. So we are going to talk about the Cisco's thing in the next 12 slides. So let's just see what's going on. First of all, you can see that it is exponentially growing. Now, all of this is projected, right? 2013 is measured maybe, or 2012 is measured. Everything else is projected. So this is exponential growth. And the growth rate is 66%. Alright? Now you can see from 66% whether it is faster or slower than the Moore's law. And I haven't calculated that myself. But basically, that's where you have to do. If suppose it is faster than the Moore's law, then what it says is that the hardware will become bottleneck and we will have to do something for the hardware. Right? And lots of hardware companies will be formed. If it turns out that it is slower than the hardware, is slower than the Moore's law, then people say that, well, we will have a lot of hardware available and nobody want to use it. Everybody will disinvest in the hardware companies. And believe it or not, these things are what make an economic cycle. So in 2000 it was predicted that the traffic will take over like this by a factor of 2 every year, and the electronics will not be able to make it because the Moore's law will not be able to take it. We will need optics. So there was an optical hype. Billions of dollars were invested on the optical companies. In 2001, they all went down. Billions of dollars companies lost. Nardal went out of business. Lucent went out of business. So these graphs can make or break the companies. Okay? So they have to very carefully find out what is the growth rate of the market and of the equipment. And so supply and demand has to be met. Okay? All right. So the next thing they have to find out where the growth is. Because if the growth is in, let's say, some other country, they don't want to put money here in this country. Right? So here's the thing. So this is for different regions of the world. Latin America, right here. Asia Pacific, right at the bottom right here. Right? So now you can see, given this, where would you put your people in? Where would you put your factories or your sales or your offices or your your investment? Asia Pacific. That's where the growth is. Then we find out where the traffic is coming from, and so they put smartphones, machines, tablets, laptops, non-smartphone and smartphone, right? And again, you can see the highest thing which is on the bottom is smartphone. So they will have to really look into the growth of smartphones and things like that before they can try to decide as to where to invest and what to do. But the traffic is really coming from the smartphones, not that much from laptops and other things. Those are things of the past. Again, what kind of traffic it is? It is a video, web, M2M, file sharing. Nobody does file sharing. Actually, it looks like from this graph, everybody is just watching video. Right? Once again, we see 66.5% in 2017. Right now, we saw that it is more than 50% is video, but it will become 70%. And so, if you are doing research or if you are doing company, you will try to see how can I make that video thing better, multimedia over Wi-Fi. Right? Because there is a growth there. You're not going to worry about the file transfer, the file sharing and things like that. Yeah.
What can be categorized as a mobile M2M?
What can be counted as?
Characterized as mobile to M2M.
Mobile web.
M2M.
M2M. Oh, okay. M2M is, okay, so when we talk about Internet of Things, which actually, I think I have a slide coming up in a minute. Internet of Things is where, the devices, you control the devices and somehow they're automatically controlled sometimes, so they talk to each other. That is M2M, machine to machine.
No, I mean, what can be characterized as
Mobile M2M. Yeah. When your iPhone talks to your thermometer, okay, or your iPhone talks to my iPhone, okay, mobile to mobile. But I mean, like anything, machine M2M is machine to machine. But if one part of that machine is mobile or one partner is mobile, it will be mobile M2M. Okay. Yeah. Right now, machine to machine is much larger, but this is only mobile machine to machine, so it is much smaller. Yeah.
Does this have to be through cellular network, or can it be through something Bluetooth?
Okay, so the question is, this mobile M2M is cellular network? No. Actually, there are many different technologies that are being used, and 15.4 that we mentioned many times here is one of those technologies. Bluetooth is also not cellular, but quite a bit used, right? Bluetooth is wireless, but so there is a lot of personal area networks which are not cellular, but long distance is cellular.
How about the NFC communication? Does it count?
Right, so they should be counting all of that. They did not say it here, NFC, because probably NFC is close to zero anyway right now. But NFC would be machine to machine, right? Because just you put your phone next to something and they will talk to each other. Okay? Good questions. All right. Now, because the cellular traffic is too much, and cellular is very expensive, because cellular is licensed spectrum. They have to pay billions of dollars to get that spectrum. It's very expensive. That's why it costs so much per gigabyte of data when you use cellular. Wi-Fi is free because the spectrum is free. Right? And so what they're trying to do is they're trying to divert as much of cellular traffic onto Wi-Fi as possible. That's why your iPhone has two modes. Whenever it finds Wi-Fi, it doesn't use the cellular data. Right? And so that is the kind of offload they're talking about. And so right now it is some number, but will become a bigger number, all the way up to 46% in 2017. And that's the only way the carriers will be able to provide the services and all the traffic that we are expecting, because cellular cannot handle. They don't have any more money to buy a spectrum. Oh, by the way, let me just say one more thing. I'm sorry. Offload from cellular to fixed. Now, when it says fixed, it means that it doesn't have to be Wi-Fi. I mean, it could be DSL. Okay, so you might have a DSL service from AT&T, and they will give you a little device. So whenever you have your phone, if it is within reach of that device, it will not go through the wireless cellular. It will go through Wi-Fi to that device and go on DSL. Okay, that is offload. That is what femtocell is called. Femtocell is a cell in your home.
So this requires the, how to say that, to make use the same provider for the Wi-Fi for the wireless network in the house and.
Okay, so the question is the same provider? No. I just gave you an example. So if you have DSL, it doesn't really matter, because if you have DSL from, let's say, Charter Communication, and you have this one cellular from AT&T, I mean, the DSL guy doesn't care of this little traffic.
But if you offload the traffic, it makes the money shift from one side to the other, right?
Well, okay, they are smart enough to keep that money. And they charge you $30 a month regardless, right? I mean, so they're just trying to, I mean, why are these rules? For example, let me tell you the rules which are really not making sense. So I have unlimited Wi-Fi, unlimited data. And this, I signed up very first day when they had unlimited. Now they don't give you that service. But it is not really unlimited. Every time I use something, I get a notice from AT&T saying that you are using too much. I don't get it, but my son gets it every month. So the idea is that basically, we signed up for infinity. Right? Similarly, they don't let me do, even legally right now, they don't let me do FaceTime unless there is Wi-Fi. Right? They don't let me update any app which is more than 10 megabyte long if it is not Wi-Fi, right? Why are these? These are unnecessary rules, right? They made up because they just want to keep the money and, right? So they know all that, and they will put these rules. In other countries you go, those rules are not there, believe it or not. Okay? You go to other countries, I went to India, I went to Qatar and every other place, you can just use your phone as your hotspot, legally, because you are paying for it. Here you cannot. So, money is another thing. They just make the charging policies such that, I don't think, I can figure it out or they can figure it out, but, yeah.
When you mentioned innovation, you mentioned that Wi-Fi has to deal with things like base station transitions and multiple antennas. These are things that cellular already dealt with. Do you feel that some of the cellular technology...
No, they haven't dealt with. No. Okay, so the question is good. Is that the cellular people have figured out mobility much better than the non-cellular people, which is Wi-Fi and IP people. Okay? So yes, they have figured it out. And much better. However, there are still hiccups. Okay, so the thing is, you may be right actually. I'm just thinking about it, because all these standards we talked about, transitioning, they were all related to Wi-Fi. They were not related to cellular, because cellular have already figured it out. Wi-Fi people have not figured it out. So they are trying to do that similar thing here. Is that, so they are trying to learn from cellular in some sense, yeah.
So you think they'll take the technology from cellular and retool?
Well, they cannot take that technology as it is. And we will talk about their technology. The cellular technology is very much, it's not really efficient and it's not really open. It's very closed. So let me tell you how it happens. So suppose you go to let's say San Francisco. You use this cell phone, which is allowed. The way it works is that when you turn on the phone, the San Francisco tower looks at your number and sends the message to St. Louis saying that this guy is in San Francisco. Can he use the phone? And the answer is, no, he doesn't have a roaming plan. Don't let him use it. All right? And somebody calls you, their phone comes to St. Louis, and then St. Louis will say, he's in San Francisco, so let me send it. So it's not very efficient. All right? And the way they do it, they keep a list of all the phones all over the world where they are in a database. Okay, all the time. And with Wi-Fi, it is very difficult to do that kind of thing. Right? So, yeah, something different slightly. All right. So, mobile video, we already said that in the very first slide, but this one shows the projection as to where it is going. Mobile video was 50%. Is this a repeat? But anyway, it's going to 66%. I thought we talked about video twice. No, maybe not twice. 66%. 66%. Okay. I went backwards actually on this slide. Sorry. So moving forward. Moving forward, 3G and 4G. So the 4G is just coming in. 3G is taking off. 2G is going down, as expected. I think this 4G forecast is probably pessimistic. I think it's happening faster than that. This probably is. This shows that for several years, but I don't think so. I mean, 4G is everywhere right now, and everybody is using it. I mean, if you have 4G, you don't use anything less than 4G. Traffic volume again, and this is a projection from them. 4G traffic is almost comparable. Well, right now it is not, but it will become comparable to 3G. Again, these projections will change very fast. I mean, I can tell you the difference between 3G and 4G is so large. I was just, last week in a foreign country. I bought a 4G device for that country simply so that I could really feel the difference. There is a big difference in the speed, right? So 4G is going to grow much faster, and it's not that more expensive either. But at the same time, the traffic is very skewed. It's so much skewed that if you take the top 1% people who use the most data on the cell phone, like my son, basically, this is my generation and my son is second generation, right? And I'm sure you probably guys do the same thing, is that he doesn't do anything on the laptop. He doesn't do anything. Everything he does is on his iPhone, right? And which means watching video or doing anything, so that is why, mine is 200 megabyte a month. His is more than 3-4 gigabyte a month, right? And that's what your generation is. I'm sure you probably, I don't know, have you measured your own data usage? How much does it come out to?
Using Wi-Fi.
Not Wi-Fi, not Wi-Fi. Whatever you have to pay the AT&T. I mean, you haven't seen the AT&T bill or anything. You go to the website, they show you how much data you used over the last 1 year.
It depends, capped by the plan that you use.
Yeah, right. I have an unlimited plan, but I use only 200 megabyte. I just checked that one.
Now they have 3 gigabyte and 5 gigabyte plans.
Yeah.
I only use like 200 megabytes because most of it's Wi-Fi.
Yeah, no, because you are so much sitting. You guys are computer scientists. You probably don't use iPhone that much, right? I mean, you use laptops a lot more than normal people will do. So you are more computer oriented. All right, coming back to this 1%. So the 1% of the people use 52% of the traffic. That's an extreme skewness, right? It's not even 80-20 rule. 80-20 rule says that the 20% of the people will use 80% of the resources, whereas 1% of the people using 52% of the resources. However, it is going down. You know why? Because the AT&T is making all kinds of rules. Right? If you are in this 1%, you will certainly be disconnected. Find your own provider. And so on and so forth. So this is going down. Cellular versus Wi-Fi. So you can see, as expected, people don't use that much cellular, they are using mostly Wi-Fi. Right? Because it's free. It doesn't count in your quota. And nobody keeps track of it. So for example, I know how much cellular data I'm using, but I don't know how much Wi-Fi data I'm using. Now I know, because when I was in this foreign country, I didn't have Wi-Fi in the hotel. So it was all 4G. And I used up, I first thought, I just need 200 megabyte. I use 200 megabyte a month, so I will probably use 200 megabyte a week. You know how much? I used about 1 gigabyte in 2 days, 3 days. And not downloading anything, just, normal things that we do. Right? So that's where it is. It's basically, Wi-Fi is something that is not visible, so at home we don't see that Wi-Fi. But abroad you have to see that one, because if you don't have Wi-Fi, you are paying for using the cellular. Machine to machine. All right. So machine to machine includes security. Yeah, well, here's the thing, security is a lot of data right there. Everybody has security cameras, right? And you can see that, and that is a lot of things. I do the same thing, my house has security cameras and we see it on the iPhone. When I was abroad, I was looking at that, maybe that was some part of the data. So that is machine to machine. Health. A lot of people have sensors that, communicate with the doctors, hospitals, and other sensors. That is what the Internet of Things is. And 59% of 3G, 32% of 2G, and 9% of 4G. Well, it doesn't really matter. Really, the thing is that this is all very exponentially increasing, and I think here, through all these graphs, I feel their estimate of 4G is sort of pessimistic.
Sorry,
Yeah.
here the LT is included in 4G or 3G?
Yeah, 4G. No. They will never include LTE in 3G. Yeah, LTE is 4G right now, by definition.
Your mention is 3.9.
Yeah, then let me tell you two definitions. Let me just say one more time the same. Marketing definition used by the industry, the technical definition used by people like us, who develop the technology, by the technologists.
Okay, Cisco says.
So the technical people, if you go to IEEE meeting, it is 3.9G. If you go to some CES show, CES, the Consumer Electronics Show, it is 4G. All right, machine to machine again. How come? Machine to machine modules. Okay, sorry. So this is the number of millions. This is the number of modules that are being sold. And the second one is the traffic. Again, everything is exponential. I think, again, as I said, the number is not important, but now at least you know that there is so much machine to machine. After listening to this lecture, you are familiar with now machine to machine, what is going on here. IPv6 is another question mark as to how many people are going to use IPv6. And this is the projection saying that all the way up to 4.2 billion in 2017, which means that IPv6 will take over the world. Again, that has to be seen. All right, I think we are done with the Cisco part. Now we go to another place where I trust quite a bit, ITU. So every year, ITU actually publishes a report, ITU, International Telecommunication Union. It publishes a report, so for example, this says world in 2013. Similarly, they had 12 and 11 and 9 and 10. So the latest figures are showing this one. And obviously they have, I think, somewhat believable data. As compared to small companies like Gartner and other people, they just take a sample. ITU probably gets the data from all the telephone companies and adds them up. So it's much more reliable. So you see, the world population is 7.1 billion. The number of cell phones is 6.8 billion. Okay? So that's the kind of thing that you really need to remember, is that basically the number of cell phones is equal to the population almost. Now, that doesn't mean that everybody has a cell phone. What it says is that some people have 2 cell phones and some people have 0. All right? And so you need to know where they have 2 cell phones and they have 0. So here's the list. This is again from the same ITU. In Africa, only 63% of the people have a cell phone. So there is 1/3 of the people who don't have a cell phone. Right? But you go to CIS. What is CIS? CIS is Commonwealth of Independent States. What is that? That's the Russian states. So Russia was a big country. It broke up into pieces, and that is called CIS. All right? And I am surprised actually that they have more than one phone per person. I don't know what they were doing with all these phones, but 1.7 phone per person in Russia. Okay? America, we have only one phone per person. Then again from the ITU, I took this graph, and the color actually is just indicating the region, so it's not really meaningful to look at the color. What I wanted to do, I wanted to redraw this one, but I didn't get time to. But basically, the idea is the growth rate. What you have to see is that in America, 48% is the penetration of the mobile broadband, means high-speed mobile access, right? And 48%. And it is growing at 28%, right? And so on and so forth. So you basically, people in the business need to know where the highest growth is. So that's where to go and invest the money. 82% in Africa. All right? That is the highest growth rate, obviously, because nobody has anything else. They don't have a wired infrastructure, so they don't have fixed broadband. And so mobile is the only way they can get to the internet. Right? And so that's one place. And next one on the list is Arab states, 55%. Same thing. They don't have so much of a ground infrastructure. And 55%. And so on and so forth. So you just look at the penetration. That tells you how much market is left. If the penetration is 100%, you don't want to go to that market. Not that much. Right? So there is opportunity, penetration is the opportunity, and the CAGR is the growth rate. So you do that, right? And the total. All right, so much about these. Now we will just talk about some observations, I would call them. I put them as trends, but these are the observations. And I wanted to start with the first one that we already said in the very first class, but since this is a whole lecture on trends, I didn't want to miss that key trend here. So this is a repeat from the first lecture, that the access is all wireless. All right? And it is really difficult to believe that we just started in 14 years ago, and now it is 100%. So, and we define the access. Anybody remembers what the access is? What does access mean? Yeah, go ahead.
The way you connect to the core?
Yeah, the way you connect to the telephone company. All right, so the network between you, the user, and the telephone company is the access. Once it goes to the telephone company's first point, then it is the core. All right, the core is all wired, of course. So the thing is, that is, most of the devices use wireless, and it turns out most of the devices use tons of wireless. So your little phone has 2G, 3G, 4G, Bluetooth, NFC, you name it, but it has no wired. It has no Ethernet. End user computing is all mobile. And again, it is difficult to believe that just 5 years ago or 6 years ago, Apple introduced the iPhone, and now suddenly people are forgetting the laptops and everything else. So now most people have smartphones in the United States as well as worldwide, and that is how the internet, that is the main way to get to the internet, is through your mobile phone. A large fraction of the population uses smartphone and tablets as the sole computing, communication, and entertainment device. That's it. So they don't have any other computer. They don't have any other device. That's the only one. Okay? Smartphones, maybe tablets at most. If they like, they might have a tablet. But tablet actually fills up the whole computer need anyway. And the operating systems of today are more Android and iOS, and the Windows. Even Windows is about mobiles, so nobody cares about anything else now. Okay, so the whole world is becoming mobile. We talked about this too, I think, last time. Most revenue is there. And we said that the growth in the wireless is expanding and the wireline is decreasing. What I did at this time is that even if you are not in the wireless business, you are in whatever business, coffee business or oil business, if you want to advertise, the only way to the real place is the mobile advertising revenue. So this is 2012, 13, 14, you can see keeps going up. So we said last time there are lots of jobs in wireless. We said lots of money in the wireless, and now this is more money in the wireless. All right, another trend is that the apps have become distributed. So now one more thing, let me tell you. Before iPhone, before 2007, the software market was centralized. Just like the music market was centralized. You had to buy a record from a record company. You bought an operating system from a big company. You bought an application from a big company like Adobe or something like that. But suddenly, one of the things that they changed was the marketing. How do you sell software? Actually, first Apple did was they changed how you sell music. Right? They started selling songs for 99 cents. This succeeded. That gave them an idea that we can sell the software for 99 cents. So now today we are all buying 99 cent software. Right? And the interesting thing is, because of this distributed nature of the whole software business, anybody can be a software developer. Every student here can write an iPhone program, game, upload it to iOS or to Apple market, whatever, and then the Android marketplace, and they have a company. Very low investment, right? And your potential is very high in the sense that you could make millions, even if 99 cents a piece. Right? This was not there 5 years ago. It's difficult to believe that. Right? So the world is becoming distributed, and so has the software industry. So the desktop era, the software were in thousands of dollars. Now they are in dollars. 99 cents is an expensive software. I don't buy 99 cents. I buy only free. Right? But they make money, out of that. Still they make money because they get advertising. So they're not losing money. Except that, I feel that I got it free, although I get hooked once in a while, and maybe their advertisement succeeds and, they made up their money, right? But that's what it is, 99 cents. Millions of app developers versus large software companies. Large software companies are having trouble now. You know that. Personal apps to enterprise apps. So there are apps which are for persons and there are apps for the companies now. So the latest trend in the app market is to have the apps for the companies. How do they do their sales or anything like that? Basically, every company needs an app for every little thing. Enterprise apps. Now, there are 2 billion apps with 50 billion downloads. Now, if there's a 50 billion download, let's say 50% of them are free. I don't know how many are free. So there is like that $25 billion market. Right? And not all of them by 99 cents. Some of them are $11.99 and $12.99 and $19.99 and so on, right? 70 app stores. Mobile presence is critical now. So if you don't have a mobile app for you, your business, you are out. If you're a newspaper, your university, your whatever, you have to have your own app. So Facebook, New York Times, etc., etc. That's another trend. Now, second thing is the cloud computing and storage is actually helping mobiles, and the mobiles are helping cloud computing and storage. How? Is because mobiles do not have enough computing power and enough storage. They need the cloud. And the cloud actually is would not be successful if there were no mobiles. I mean, a lot of people will not go to. Before mobiles, actually, I think Dropbox was there. I may be wrong about this, but there were other, Google storage space was there, but I didn't use it. Now I use all of these because, mobile. And the biggest thing is the wireless has become fast enough. If the wireless was slow, we won't use cloud. Right? Nowadays, the wireless has become so fast that we don't feel the difference, whether the information is here or there. So those two things, the development of mobile and the development of the speed of wireless, has caused the cloud computing and the cloud storage to suddenly come up. Now everything is cloud. Your computing is cloud, so you have Google Docs and Office 360 and whatever. Your storage is cloud. Dropbox, SkyDrive, iCloud, you name it. Internet of Things is happening. Internet of Things basically is the idea that only 1% of the thing is connected. Things that need to be connected is 99%. Your refrigerator, your thermostat, your car, your heart, your money wallet, I don't know, everything else that you can think of, your glasses, they all need to be connected to the internet. Right? If your glass is connected, you can watch the internet right here. I mean, you can watch the movie rather than watching it on the iPhone. And so that's what people are doing, right? So you have to have everything connected, and so 99% opportunity right there. And that is what the Internet of Things is all about. So 10 billion devices today to 50 billion in 2020. And so we need everything about those things, Internet of Things. 14 trillion market. So we're talking about billions here, yes, trillions here, right? And that is where now these companies, Gartner, Cisco, and everybody else is looking for getting in. Now, this is Internet of Things. Cisco calls it Internet of Everything. Why everything? Because things and people combined is everything. Okay? So they want to combine the two. IBM calls it a smarter planet. Obviously smarter everything, right? GE calls it industrial internet. CPS is another name for it, cyber physical systems. Internet, and some people call it Internet of European things. You know why? Because it started in Europe. For when we were doing research in next generation internet 5 years ago, so in the United States, nobody was working on Internet of Things. There are people in Europe working on Internet of Things, and we said, oh, this is a topic that nobody will want ever. We didn't pay attention to it. So that's what it is. Now we are feeling that, maybe we should have done some paid attention. It's more popular in Europe than USA. Anyway, coming back to what is happening in the academic world. So I went to IEEE, Communication Society, Digital Library, and they have a list of top 10 downloads, what people are reading, what faculty members are reading in networking. Now, by the way, Communication Society is networking, not just wireless. Everybody is networking. What are the professors reading? Here are the top 10 downloads. And you count, 7 of them are wireless, 2 of them are SDN, and 1 of them are security. What is hot? Wireless. Then SDN. And then security. And that's it. That's the end of the top 10. Alright. Luckily, this is just I discovered yesterday. The last article is mine. Okay. I was really surprised because we just published it. This article appeared in November 2013 and it came up on that list. So I don't know. But the list is not just 1 month. The list is from 2002. So that, not 2002. There are papers here which are 2002, 2005 and so on and so forth. If you go there, you will find the dates and everything else. But I was really kind of happy to find that my article is in there. But anyway, so this is, this is what is happening. So another cartoon just to show you where the wireless is taking us. If you have no wires, you don't have to live in the cities. You don't have to face the traffic. You can live in the boondoggle, you can just live wherever you want to, and you are fully connected. So this is what the world will look like in 2020. You will move to the caves back. Right? The reason we are living in the cities is because we need to be connected. Right? Now we are going back to the old days. Now the question is where people are spending the time. And this is another interesting one I found, is that look, we think that all this mobile and the traffic and high speed and everything else will make good use for us. Only 2% productivity. 2% on productivity. Everything else is games and entertainment. And this is really interesting because the country with the highest speed internet is Korea. They have a gigabit fiber to every home. And you know what they found out? They found out that their children are not studying anymore. They are playing games all the time. Right? Such a high speed access that they don't need to study anymore. So that's the danger of this thing, is that you can see right here that with mobiles coming in, people are on Facebook and games and whatever else they're doing, but productivity is only 2%. And the world has become very fast. It took 38 years for the radio to become 50 million people. The radio, the normal radio that people used to hear before, radio stations, it took 38 years. 13 years for TV, 4 years for the internet to become 50 million people. 4 years. Facebook, it took 3.5 years. For the app, it took 50 days. In 50 days, you can have 50 million people. Right? There is a big opportunity right there. That brings us to the end of this lecture. And you may not remember all of these things, but I just put down 5 things, key summary that I kind of clearly remember. One is that the world Wi-Fi has grown up worldwide just in 15 years. It is difficult to believe that 15 years ago there was no Wi-Fi. Okay? Then some of the technologies that we should be reading about or researching about are 5G, cognitive radio, M2M, terahertz, smart antennas, LTE advanced, etc., etc. Wireless speed growth is following the Moore's law. Okay? That is, at least we can remember that much. Mobile subscriptions are approaching the world population. That was another interesting fact that 7 billion people, 7 billion phones. That is, population. And most of the traffic is video, and most of the growth is in Asia Pacific. Okay? All right. And the reading list is you must read. Okay? As I said before, I very carefully put items on the reading list. These are the things that you must read. Then there are Wikipedia links, which in this particular case you don't have to read, because these are basically, if you need to know what is white spaces or what is LTE advanced, I put one line there, but if you need to know one page, you go to the Wikipedia and you find it right there. You can just click it here and you get it there. But this is, I'm not expecting that you will know more than one line about those technologies. So don't worry about those. And then there are references. Now references is everything else. If you are writing a survey paper, then you will read the references, but I'm not expecting you to read it. If you read it for your pleasure, good for you. Okay, it will help you. Because I read them, I found them interesting enough to put them on the references. There are lots of things that I don't put on the references because they're not interesting enough. Okay? So this is references, there's a reading list. Reading list, please read, okay? And then acronyms.